Hello and welcome to Train Signal. You are watching Email and Printing. Have you ever sat in your office or cubicle a mere 10 paces or less away from a coworker that you just fired off an email or instant message to? Well, I've done the same thing, and this is the world that we live in now. Email has become as integral a part of the enterprise as the products or services that it sells. Just the thought of being without my beloved email accounts, all 5 of them, for even a day is enough to send me into a panic. When we think about email, we think of the major contenders like Yahoo, Gmail, or Hotmail, and client programs like Outlook and Thunderbird. And in the enterprise, there are even more options. Yet email for a Linux administrator is another matter altogether. Driven from, as you might expect, the command line, this email system is used by many system services, like cron for instance. Another important aspect of any business is its printing capabilities. Like any decent networked environment, Linux provides more than adequate facilities to handle all your printing needs, albeit a little differently than what you may be used to in Windows. So in this lesson, we'll start with an overview of email basics, then we'll talk about the different email software options available under Linux. From there, we'll move into how to manage and perform basic tasks with email, things like sending and receiving mail. The next section of the lesson will cover printing basics, including the common Unix printing system, and we'll wrap up with how to manage the print queue. Let's begin with email basics on the next slide. Email is a modular process, meaning there are several components that make up the system, each with its own part to play in message delivery. First, we have a protocol, which at its most basic is a communication scheme, essentially a program that allows dissimilar systems to communicate. Under Linux, there are several protocols that can be used to manage email, but there are 2 that you should be most familiar with, mainly because they are the most commonly used, but also because they are what's covered on the Linux Plus exam. The first is Simple Mail Transfer Protocol, or SMTP, which is a push protocol, or one that handles sending data. But of course, sending is only half the picture. For the other end, you need a pull protocol like Post Office Protocol, or POP, or Internet Message Access Protocol, or IMAP. With these 2, the receiving system initiates the transfer, and this is useful because user systems aren't always turned on, so when they boot up and are ready, they can initiate mail transfer. POP pulls messages and deletes them from storage, while IMAP, which is probably the more powerful of the 2, allows you to retain a copy in what's called a message store. So we have a message that using SMTP is transferred from the mail user agent, or MUA, on a sender's workstation. It goes to the mail transfer agent, or MTA, on the email server, which uses the SMTP protocol. If that message is intended for a user on the same domain, the message is held for delivery by the local MTA. But if it's intended for someone on a different domain, the MTA then forwards the message through other MTAs on the network until it reaches its destination. And further, as these messages are sent through each MTA, it's altered by adding a header to the email, which provides information about the message, usually including the path that the mail is taken. And behind all of this operation is a mail server which holds email for each user, usually in var, spool, and mail, under a directory for each user. But this file can also be stored in the subdirectory of a user's home directory. And this incoming mail file is called the mail spool. To receive mail, users will use an email client or a mail user agent. Usually the client can contact a remote server to initiate mail transfer. Let's move on and talk about the different email programs or mail transfer agents. You probably already have an email server installed on your system. Which one you have will depend on your distribution. There are 4 most common servers. SendMail is the first, though because of its difficult configuration file formats, isn't the most popular option anymore. There's also Postfix, which was designed as a replacement for SendMail. This is the Fedora Linux default server. Next we have Exum, which is a singular system like SendMail, but it's a little easier to configure. And finally we have Qmail. This is the most security conscious server even though surprisingly it isn't the default server for any Linux distribution at this time, mainly because of some licensing issues. So how do you tell which system you're using? You can use the ps command that we learned about in the GNU and Unix commands lesson. This of course checks for processes. Another option is to use the package manager to see which one is installed. Let's go open a terminal window and try out a few options to confirm what we have on our test system. Let's open a terminal window with Applications, System Tools, and Terminal. Now we're going to use the ps command that we learned about to list processes along with the grep command to do a search. So let's type in ps space ax, and I'll explain everything after we finish entering the command, space pipe space grep space send. This command says to search for the send process, and the A option means to search all processes, and X increases the amount of information displayed about the process. And again, the grep command says to search. And we're going to search first for sendmail. And hit enter. And you can see that we indeed have sendmail running. It lists some information about the spool and the client. And it says it's accepting connections. If you didn't find sendmail on the first try here, then you can try the other options in turn using the same search command. Now let's take a look at our graphical package manager. Let's go to System, Administration, and Add Remove Software. And on your Ubuntu system, you could also use Synaptic. Let's type in sendmail in the search bar here and hit enter. We see that the query has started. And if you look here with the check mark, you'll see that sendmail is installed. So there are two ways that you can confirm it, either using the graphical package or from the command line. So just went ahead and close that out. So we've talked about the function of pull mail servers and how they initiate email receipt. There are two packages that are common, Cyrus IMAP and Dovecot. Next we have fetch mail, which is used in those cases when you want to use a variety of email clients, or if you want to run your own SMTP server or a POP or IMAP server to deliver local network mail. Fetch mail pulls mail with POP or IMAP and injects it into a local SMTP mail queue. You probably won't use this option very often. And finally we have mail readers or clients like Evolution, which is the default reader for Linux, and you have Kmail, you have Pine or Mutt. Let's move on and talk about accessing your mail from the command line on the next slide. The most basic command line email program is simply called Mail. With Mail, you can send and receive email using the following commands. The first is send with the format mail space followed by options followed by the email address that you want to send to. The options are -V, which produces a more expanded output, -S, which is used to specify the subject. Then you have -C and -B, which are used to specify carbon and blind copy respectively. And finally you have -F, which is used to read mail. Optionally you can include the mail spool file or the -U option to read the mail of an individual user. Nail is an alternative used by some distributions, and some of the options are different, but Nail can also use the options that you see here on the screen. One difference in particular is -A, which for mail with an M inserts a header, but for Nail with an N is used to attach a file. Let's go back to our terminal and try out this command. A required program that may not be installed by default on your system is called MailX. To determine if we have it installed, you can use a command line option or you can look at the installed software again. Let's type in mail here and hit enter. The error that we get, bash mail command not found, tells us that mail is not installed. So let's go ahead and install it. I am partial to using Yum, but again you can use either of the other options that we've covered. So I'm going to type in yum install mail X and hit enter. And we forgot to obtain root privileges, so let's go ahead and do that. Let's type in SU for switch user, then our password. If I type that in correctly, let's try that again. This time I will not fat finger the password. Okay, from here let's type in yum install mail X and hit enter. Again, yum has told us that it's going to install one package, gives us the architecture, the version, the repository, and the size. And if you're happy with all that, go ahead and say yes. Then the download and install will proceed. Okay, now that that's complete, let's go ahead and email one of our test users. Now, if you don't recall which user that you set up, and if you want to see a list, you can do so from the command line by typing in ls/home. And again, all regular users will have a home directory. And here's some of the users that we created in some of our previous lessons. I'm going to send Nancy an email. So I'm going to type in mail space -s for the subject, which I'm going to enclose in quotes. Subject is going to be lunch. And I'm going to carbon copy V. Henry, and we're going to send the note to Nancy and hit enter. At the prompt, you type in the message that you want to send. And I'm going to type in, let's meet at noon for lunch. You end the message with Control D. Now let's type in mail. And again, the mail command is used to display the mail that's in your system. You see here that we have 7 messages, 2 new, and 7 unread. Looking at the format of the queue, we have the sender, we have date and time information, and if you want to read the message, you type in the number that you see here in the second column. And as you might have guessed, U represents unread and N represents new. So if we wanted to read a message, let's type in the number, which is 7. And you can see some header information here, who the message was sent to, the subject, carbon copy, and then we have the actual message here. If you wanted to delete a message, you type in D, and if you wanted to reply, you do so with R. So first let's reply, hit enter. I'm going to type in sounds great, and Control D. Let's type in mail again. What we're going to do here is enter another mail using the command line. So we typed in who we want to send it to, and I'm going to send it to Nancy. And the subject is, just make it test. We'll type in, this is a test. Then we'll Control D. We have an indicator here that we have a new message that has arrived. We've got the new message here. Let's type in Q to exit. And again here you see that it indicates that we have 8 messages, including the one that we just sent, and it tells you where the mail is stored. It's in var spool mail Henry. Now let's type in mail again. Hit enter. Now let's go ahead and delete a message. I'm going to do so by hitting the D, and then let's say number 7 for message number 7, and hit enter. Hit Q to quit. Let's type in mail to take a look at them. And we'll see that the message I deleted is indeed gone. Okay, I'm going to hit Q to exit again. And now let's go back to the presentation and talk about managing the email queue. Mail queue is the main email queue management program for Linux. Typing in mail queue with no options will display the entire queue. And it's equivalent to typing in send mail with the -B and P options. Now if you wanted to clear your mail queue, you use the command send mail again, but with the -q option. On postfix, the equivalent is postq, and on exim, the equivalent is runq. We first talked about aliases in our GNU and Unix commands lesson, and we learned how they can be used to give new names to regular commands. With email, an alias can allow one address to accept mail for another. For example, a basic Linux email account is called Postmaster, and if you wanted to assign a user to read mail for this account, you'd set up an alias by editing the aliases file in etc or in etc mail. The format is simply name, address 1 followed by address 2, etc. Where the name is of course the local name like Postmaster, and address represents the forwarded message addresses. Normally there's only one, but you can certainly have 2, 3, or more. Normally Postmaster is alias to root, but reading mail as root is a security risk. Just imagine opening and reading a tainted email with admin privileges. For this reason, root also usually has an alias of its own. Some mail servers, including SendMail, Postfix, and QMail, require that you compile etc aliases into a binary file so that it can be processed quicker. You do so using the command new aliases. Another way to redirect mail is to edit the user's forward file, and this is located usually in the user's home directory. Now let's go back to our terminal window and take a look at our mail queue. Now to check the mail queue, you will need admin privileges, so make sure that you're still logged in as root. And now let's type in mail queue. Mail queue. Hit enter. And you see here that it lists the mail queue file. Now the email queue is normally empty, as message delivery usually takes place relatively quickly. But if there were problems with email delivery, messages would be stored right here in the queue. Now let's see what type of email aliases that we have set up. Let's type in cat space etc aliases and hit enter. And let's scroll up to the top of the file, and we can see that we have some comments here. And then we have some basic system aliases, which include Postmaster and root. Then we've got some general ones here as well. And they follow the format as we've just learned, which is name followed by the redirect or the alias address. Now let's scroll down to the bottom. You see this last line here where it says root is redirected to mark? Oh, the panic that set in the first time that I saw this. But have no fear, this is the default setting for Fedora. And what you should do is just go in and change it to the username that you want. Let's edit this file right now by typing in vi to launch the vi editor. And we're going to type in the full path to the file, etc aliases, and hit enter. We're going to hit I or A to enter insert mode. Then we're going to page down, just using the page down command. I'm sorry, the page down key. And now I'm going to go over and type in vhenry here. And you can select the user of your choice, a trusted user, I should say. Now we're going to hit escape to enter command mode again. Then we're going to enter :WQ to save and quit. There are two primary threats to email security: bugs and configuration errors. Now bugs are just what they sound like. They're flaws in the program code that can be exploited by attackers and used to compromise your system. But the other problem relates to the administrator. And a common one is to configure email as an open relay. And what this does is allows your system to relay email messages from any computer to another. Now spammers used to use this method as a means to send their emails while masking their identities, but most have moved on to far more sophisticated methods. The best defense in either case is offense. Ensure you have the most up-to-date versions of your software and that you've applied any appropriate patches. And always check your default configuration to make sure that your server isn't set up for open relays. You don't have to worry about this configuration in detail for the Linux Plus exam, but you should understand the nature of both threats. Now let's switch subjects and talk about printing on the next slide. One of the most important services offered by today's networks is printing. Think, for example, of a newspaper or a magazine, industries that rely on printing as their primary business. Now imagine if reporters were somehow no longer able to send their print jobs or other documents for output. Then you also have online retailers that need to print an invoice or a packing slip with every order, and imagine them not being able to do so. The importance of printing should be becoming crystal clear. To understand how Linux handles printing, we need to go back to our lesson on X11 installation and configuration. This is where we first talked about PostScript fonts. If you recall, most apps generate print jobs using Adobe's PostScript language, but most printers aren't PostScript compatible. Enter GoScript. This is an open source program that converts the job to the proper format, and it uses smart filters to ensure print queues are ready to handle that data. Now the only drawback to GoScript is that it does produce large output files, but this isn't usually a huge problem as printer files are usually only stored temporarily, and modern systems don't have the same hard disk space issues. Like other daemons, the printing system must be configured to start at boot up, and as we've learned, this is done through configuration files usually stored, depending on your distribution, in either etc rc.d, etc init.d, or etc rc?.d, where the question mark is usually replaced by a number. The startup script will probably contain a string containing the word cups. Let's talk about what cups is on the next slide. The most common Linux printing system is Common Unix Printing System, better known as cups. The cups daemon runs in the background and controls the availability of print queues so that your users' client machines know which printing options exist at any time. Cups configuration files are stored in etc cups. Now you can add or delete printers using the web-based utility that we'll cover in a moment, or by directly editing the cups.d.conf configuration file. The format for each entry is simply default printer followed by the printer name enclosed in angle brackets. Each printer definition contains information on the printer's location and things like status and other options. And additional options are stored in PostScript printer definition files, named after the queue, and are stored in etc cups ppd. Settings for each printer section of the configuration file could include directive orders like deny and allow, default policy options, browsing control, which indicates from whom it can accept browsing requests, access control, which usually mirrors browsing controls. Then you also have enable browsing and browsing access control, which controls the broadcast address. And again, though you can edit the configuration files to add printers, the preferred method is to use the cups web-based configuration tool. This tool uses the Internet Printing Protocol, which allows network printers to exchange printer lists. As the name suggests, you can access cups through a web browser. Let's go back to our terminal window and take a look at both our configuration files and cups. Type in cat space etc cups cupsd.conf. Got etc cupsd.conf and hit enter. Let's scroll back up to the top. Now I don't have a default printer attached, so you won't see any options for that, but what you do see here is browsing on, browsing order, and some of the other options we've talked about. Browse allow. The file is actually pretty well documented, and you can peruse it just to get an idea and a better understanding of the work that cups does behind the scenes. Got some policy information here. Some settings for administration, operations, etc. Now, if we want to take a look at cups, we're going to have to open a browser. Now I'm partial to Firefox or Chrome, but anyone will do. So I'm going to go ahead and click on Firefox icon, and I'll just minimize this to get it out of the way. Now on the URL line, we're going to type in http://localhost:631. So again, that's http://localhost:631, and hit enter. And this is the CUPS utility program. You have some tabs across the top. And on the Home tab, you see we have an overview here. We have a listing of options, some forum listings, and what's new in CUPS. Then we've got some administrator options, adding printers and classes, managing operations, accounting basics. We've got some security options, and some authentication options as well. Then we've got some information for developers, people who want to work on programs to enhance CUPS. Let's look at the Administration tab. Again, you have options to add a printer, to find new printers, manage printers, and the same information for classes, which we won't have to review, and jobs. Over here, we can edit the configuration file, take a look at the logs, and there's some more settings here. Let's just click on Add a Printer. And as you can see, we don't have an actual printer to add, but I wanted you to see that what's first required is the username and password. Let's cancel out of there. I'm going to hit the back button. You can look for new printers here, and again manage any printers that you have connected to the network here as well. And here is Online Help, again where you can get help about the program. And the final tab, Printers, you can actually enter in a search string for printers. Okay, I'm going to go ahead and close this out. Now let's go back to the presentation and talk about some more command line options for managing the print queue. Many of today's networks have a combination of Windows and Linux boxes. And Server Message Block, or SMB, and Common Internet File System, or CIFS, allow for file and printer sharing between them. To print to a Windows machine from Linux, you must provide a password, a server name, and a share name in the format SMB://username:/password@ followed by the name of server or the share. And though CUPS is commonly used today, it did have a predecessor, and it was called Line Printer Daemon, or LPD. LPD used the format LPD://hostname/Q. But you probably won't see this option very often. And you've probably guessed that there has to be a way to manage print jobs from the command line, and you're right. The first is LPR, which is used to submit a print job, and it takes the options -P to indicate the print queue, -r to delete the file after it prints, -H to suppress the banner. Then you have -J, C, or T, which can be used to change the job name. Then you have -m, space username, which emails a user when the print job is complete. And finally we have -pound, followed by number, which is used to specify the number of copies. Another option is MPage, and this is useful for formatting documents so that each sheet contains a reduced size pages. The next command line tool is LPRM, which removes a print job from the queue. And finally we have LPQ, which displays the print queue. And that concludes our lesson on email and printing. Let's review what we've learned on the next slide. Email is a cornerstone communications method for today's organizations and individual users alike. And as an administrator, you must have a sound understanding of how to configure and manage email for your Linux servers. Along with email, printing is one of the most important network functions. Linux handles printing support quite well. There are both command line tools, like the ones that we reviewed, and the web-based tool, CUPS. So in this lesson, we covered email basics, how email works in Linux, the available software options, and how to manage it from the command line. We wrapped up our email review with a look at security best practices. We then moved on to cover printing basics in both command line and the web-based tool CUPS. CUPS again is used to add or remove printers, and we also learned how to manage our print queue. Thanks for watching, and I'll see you in the next lesson.